In this video we'll discuss about Vernier calipers. So before why we should use Vernier calipers, we should know that steer rule, the least count for steer rule is minimum least count. What is least count? Least count is the minimum distance which we can measure using an instrument. Okay, so the least count of an steer rule is usually 1 mm. So if you want to measure anything less than 1 mm, then you have to use Vernier calipers. Or if you want to be more accurate, more accuracy in your work of measurement, when you are assembling motors, or installing bearings, calculating the filler gaps, okay, that time you need to use Vernier calipers, okay, or filler gauges. That time you need to measure the distances in less than 1 mm. Okay, so let's see. Here I have a steer rule. Steer rule, if you can see, it's metric. So you have here 10 mm or 1 centimeter. So you can see this 10 mm or 1 centimeter divided in 10 parts. You can see 10 lines. So the least count is 1 mm. And here below, sometimes you have the special graduations which the least count is 0.5 mm. Okay, lesser than this you cannot go with steer rule. So if you want to measure something very less than 0.5 mm, you can use Vernier caliper. So this is Vernier caliper. Okay, it looks like this. And how do you know the least count? Okay, usually it is written on the Vernier caliper itself. If you can see that 0.02 mm here, okay, that's the least count for the metric scale. Below there is an inch scale also there. Above, the least count for the inch scale also has been given there. Now, how to use this Vernier caliper? Before using, you need to know the parts. What are the parts of this Vernier caliper? So the first upper jaws which you see are called as internal jaws, and these are external jaws. So why we use internal jaws? These are used for measuring inside diameters. Okay, inside diameters. They have flattened surfaces here which will go touch the measuring sites. Okay, they are carbide, very high strength material, so they will go touch and you can measure the inside diameter. And the external jaws are used for measuring external diameter. Okay, like this. So this is the thimble. You use your thumb to move this, it will slide across the main scale. Okay, so you can measure using like this. Okay, external jaws. You should not measure using this one. You should always use this jaws for your measurement. And here also this one, not the inside one. Okay, so internal jaws, external jaws. Okay, locking screw. This one, it will lock the reading. If you rotate it, it will lock. You cannot move here and there. So it's a locking screw. And this is thimble to just move here and there. And then you see the big scale from here to here. This is called main scale. And you see the small scale. This is called Vernier scale. Okay, and once I move my Vernier caliper, you can see there's something coming and going out. That is depth gauge. Comes from here, it stays here like that. Depth gauge. So we can use this one also to measure the depth. How do I use it? I use the thimble to move it up and down and it will come. So you can use for measuring depths. Okay, but your surface should rest. Your surface should rest on that one. Okay, so to summarize, we have internal jaws, we have external jaws, external jaws, locking screw, thimble just for moving the vernier scale here and there, main scale and vernier scale. And what do you have? Depth gauge. Now, before going to the reading, we need to know the least count of vernier caliper. Usually it is 0.02, but sometimes it can be a special case like this one, and you will have least count of 0.05 mm, but still higher than street rule. Okay, so this one is basically 0.05. So you can see the graduations there from 0 to 1 in vernier scale are very less, only 1. Okay, but whereas here in 0.02 you can see the graduation between 0 to 1 on vernier scale. You see 5 parts. Okay, 5 parts, so each part is 0.02 mm. So let's know how to read them. So this is how you read vernier caliper. Okay, I move the thimble. You measure your sample. Okay, then once you measure your sample, what you will do is, first thing, see the 0 of vernier scale. Okay, 0 of vernier scale, the graduation on the 0 of vernier scale or before it, you will take it. So if I zoom in, you can see there is no graduations on the 0 of vernier scale. So we take the before one. Before or on. After the 0 we don't take it. Okay, so what is that one? 25, 26, 26. So we take 26, we don't take 27. Even if this 27 is very close, but we don't take it. It should be on the 0 line, exactly on the 0 line, like they should match. They should be like parallel, or they should be inline, collinear. They should be inline, or they should be before. So now what is the line before the 0, our vernier 0 is, you can see here, is 1, 2, 3, 4, 5, 25 and 26. So here he got 26, now 58. So this is before point. So main scale will give you the reading before point, and vernier scale, the small scale or vernier scale here, this vernier scale, and this big scale is main scale. So main scale will give you the reading before the point. So before the point. Vernier scale gives you the reading after the point. So you should remember this one. If you are in a hurry, you don't need any reading after the point. You can just directly use vernier and get reading before the point. Sometimes you are in busy and there is no need of any accuracy, so you can just before the 0 you get the size. Here there should be no mistake. If there is a mistake here, that means you have a reading problem. Okay, now after the point, how to get after the point this 58, how we are getting this 58? You can see this one if I zoom in. Okay, 26, and it is between 26 and 27. Okay, greater than like 0.5, half of the, it's like halfway through the 27, right? So how do we know this exact number, that 58? So what you have to do is, all these lines you need to check who they are collinear with. Okay, they should be like the Vernier line and the main scale line. They should join exactly like this in one line. Where this is happening, you need to know. So if you look closely, you can see at 58, okay, this is 50, okay, 51, 58, 52, okay, 58. Each division is what? 1, 2, 3, 4, 5. So each division is divided by 5 parts. That means 2. So each division is 2. So that means 52, 54, 56, 58. Here you can see exactly. That's why 58. Okay, now let's change the reading. What would be the reading? What would be the reading now? So if you can see the 0, what is this? Is 30 mm, 31, 32, 35, 36, 37. Okay, 37. After 37 we see the 0 line. So 38 we cannot include it because it passed the 0 line. So it should be on the 0 line or before the 0 line. Okay, so now it is like it has passed. It has passed. So we ignore that one. So 37. Now we need to know the distance between this. 37. So this is before the point, we got it 37. Then after the point, what is the after the point? We need to check which lines they are matching, collinear, exactly matching. Let's see. Obviously this is close to 38, right? Close to 38. That means the answer is here in this line. If it is close to 37, then answer is here. So is here answer is here. So okay, 82, 84, 82 or 84, you can say. Okay, it's exactly matching. Here it is not that much clear, but in Vernier it will be very, very clear. Okay, don't get confused, because here some lines you can see they are like matching, but okay, 84. So it will be, answer will be 37.84. okay, let's do it with real Vernier caliper. Now to measure, you have to hold the jaws like, to measure you have to hold the jaws like this. Both the jaws should touch the workpiece, and now you go there to the scale. Now what do you see? 30, 31, 32, 33. 33 is exactly lining with the 0. So what do you have to do now? Nothing, because both of them, they are coinciding. That means the reading is exactly 33. So you don't have to do anything. Right? The reading is 33. Now I will show you another example. Let's measure another thing, something else. Now if you see, we measure this one, and the answer, what's the reading? I'll go down, play zoom. Is it visible? Okay, now it's visible. You can see 45, 46, 47. So this 48 is not exactly. Let me lock it and lift. Now it was becoming difficult because since this is very long. So what you can do is lock the reading there and you can shift it, and now you can relaxedly read the reading. Now if you can see, what do we have here? We got, yes, it's like little before 48, so we cannot take it. If you can see, I am seeing like clearly, but in video is it visible or not, I don't know. If you can see in video, it is not exactly 48, it is before 48, so you cannot take 48, so you will take 47 point. Your answer will be in this side because it's very close to 48. 47 point. Now you need to see which lines are matching. So I see 48.92 or 48.96 or 98. Which one is matching close? 98. So let's say 98. So our answer will be 47. So our answer will be 47.98 mm. Hopefully I am able to make it clear. So this is how you use it. Okay, it's locked. So this is how you use it. Okay, so first reading from main scale you will get before point, and Vernier scale the after point reading you will take it from Vernier scale. How do you take this reading? Based on the least count, you know how each line is what. Like if the least count is here 0.02, so that means each line between 0 to 1, 1 to 2 is 0.02. Now, and how do you take the reading from here? Because you check the collinear line which is exactly matching and becoming one with main scale. Should be like this collinear line, collinear with the main scale division. Okay, then you take it. That's it for Vernier caliper.